The purpose of Edyza sensors is to push IoT into areas that were once considered impossible due to the lack of power or connectivity. Billions of sensors can now be powered by our suite of energy harvesting modules that harness energy from thermal using Peltier devices, solar, vibration or kinetic energy using piezoelectric devices, and the radio waves. The heart of Edyza is the sensor controller and the energy harvesting module. This quarter-sized microcontroller/wireless module works within the power budget of our energy harvesters. Having limited energy means these devices are in standby or power-off mode most of the time and are only woken up by the sensor triggers. This presents challenge in routing data through this low-power network. Edyza solved this with a paradigm shift in sensor data collection. The Edyza philosophy is quite antithesis to the prevailing motto of pushing all the data to the cloud and then sifting through this data deluge to find actionable intelligence. Instead, our model achieves complexity through simplicity like an ant colony. Let's explore a couple of energy harvesting methods in action. First, the temperature but humidity sensor module is powered using radio waves. This would find application in food but produce delivery industry. In this demo, the temperature sensor is controlled by the microcontroller and the voltage from the temperature sensor is reported using the LCD. The advancements in semiconductor industry has allowed the possibility of running a full-fledged hardware sensor application, including LCD directly from radio waves. In the second demo, I am harnessing energy from the vibration of my air conditioner. The generated voltage from this energy harvesting module is measured by the multimeter. In this quick demo, the piezoelectric module is held together by the wrench to the top of my air conditioner, and it generates enough energy to power the sensor controller by wireless module. The power supply smoothing circuit generates a constant voltage, and in this case 1.3 volt from the small vibration of my AC unit. The third and final demo, vibration energy harvesting, is used in electronic tennis officiating. The piece of wood represents one of the segments of the boundary line of a tennis court. I have attached a piezo sensor with our sensor controller module to this wood. When the ball falls on the boundary line represented by the piece of wood, it generates enough energy to light up the LED. In the full-fledged demo, the sensor controller will read in vibration data and analyze the pattern to distinguish between ball fall or a foot fall, and then pass the relevant result higher up the mesh network chain and finally to the Edyza cloud. To sum it up, Edyza helps to push IoT into areas that were once considered impossible due to the lack of power or connectivity. We provide a sensor or wireless controller, a low-power mesh network stack, and finally a sophisticated Python SDK to create, manage, and deploy sensor filters that can analyze sensor data right at the source before it hits the cloud.